Okay, so we did long division, and sometimes that can get a little grueling. There is another way to divide polynomials. It's called synthetic division. And all it is multiplying and adding, and multiplying and adding, and multiplying and adding. So, but you got to know the order to do it. I've written some steps here. You can pause it and write the steps down. So you can only use synthetic division if the divisor, what you're dividing by, is in the form of x plus a or x minus a. And what's important is that the coefficient has to be a 1. So 1, it has to be a linear, just x to the first, and the coefficient to the x has to be a 1 in order to use synthetic division. So I'm going to go through the steps as I work it out. The first problem, the first step is to solve the divisor and write the value of that x on the left side of the box. And what I mean by the box, I do a box like this. Sometimes you'll see, and your book does it like this. I'll show you kind of both ways, the same thing though. But what I'm going to do is I'm going to take the divisor, what I'm dividing by, and I'm going to solve for x. So set it equal to 0, and when I solve, I get x is equal to 2. And I'm going to use that x value on the left side of the box. So I'm going to put it here. If it's this way, it would go here. That's the only difference. Okay. Then write the coefficients of the dividend, or what you're dividing into. This is the dividend, in a horizontal line on the right side of the box. So I'm going to put the coefficients. The coefficient for this x to the third term is 1. The coefficient for the quadratic term is -4. Then I have 6, and then -4. So these are my coefficients for the dividend. Now what I do, I'm going to bring down this first coefficient and write it under the line. Then I'm going to multiply this x value with the value under the line, or the number underlined, so 2. You don't have to do this every time, but I'll go ahead and show it to you. 2 times 1 is 2, and then I write that up here. And then write that product above the line in the second column and multiply, add this to it. So you write that product above the line in the second column and then combine the columns, meaning add these two together. -4, +2 becomes -2. And then multiply with the x value again and continue. I just say rinse and repeat. Do the same thing over again. So I'm multiplying. 2 times -2 is -4. You're combining these to be +2. 2 times 2 is +4. You're combining these to be 0. So the last couple steps to finish it, these are your new coefficients, and the last one is your remainder. So when I'm writing the new polynomial, or the quotient, and so what I'm going to do is I'm reducing the degree of what it was originally by 1. So instead of being x to the third, now it's going to start with x squared. So it's going to be x squared, and then this is going to be minus 2x plus 2, and a remainder of 0, so I don't need to write that part, and that is my quotient. So the next example, I have 6b to the fourth minus 8b to the third plus 12b minus 14 divided by b minus 2. So what really just happens here is what's going to go on the left side is +2, because if I solve this, add 2, and I get +2. I put my coefficients here, 6, -8. What you need to notice still is that the b squared is missing. So you do need to have a spot for that, and it's important to put that 0 just like in long division. I have to have that 0 there for that b squared spot. And then I have 12b to the first, and -14 is my constant. So I'm going to bring down that first coefficient, 6, multiply. 2 times 6 is 12. Combine, that becomes +4. Multiply 8. Add it with 0 is 8. Multiply is positive 16. This becomes positive 28. Multiply, and that's going to be positive 56. And combine them, and that becomes 42. Positive 42. So this is my remainder, and my coefficients are going to be 6, and it's going to start now with x to the third. So I go 1 degree less than what it was originally, so 6x to the third plus 4x squared, and then I'm reducing each one of these by 1 degree, so that's going to be 4x squared plus 8x to the first plus 28. And then I'm going to write my remainder plus 42 all over the divisor, which was b minus 2. And that is my quotient. Okay, so one more thing is synthetic substitution. And using synthetic substitution is using the remainder theorem. And what the remainder theorem says is if you divide a polynomial, we're going to say p of x, that has a degree that is greater than 1, by a polynomial x minus a, then the remainder, whatever ends up being the remainder, is equal to p of a. Now what that means is p of a, remember we did direct substitution, which was directly substituting it in for x and simplifying it. Synthetic substitution, you can get that same value as you did with direct substitution by using basically the synthetic division part. The only difference is they're giving me this x value here. So when I'm trying for this first example, I have this polynomial and I'm using synthetic substitution to find p of 3. Well, that means that x is equal to 3. So I'm not going to do the opposite of that because that is the x value. That's the one difference with this problem and synthetic division, is that they give me the x value to use in that left side. So then I have my coefficients, and pay attention to your missing terms. I have 1 for the x to the fifth. My x to the fourth is missing. So that's 0. -8 for the cubic term. -1 for the quadratic term. My linear term is missing, the x to the first, and then my constant is 2. So now you go ahead, drop the first one, and that's going to be 1, multiply with 3, add with 0, multiply with 3, combine with -8, multiply with 3, combine with -1, multiply with 3, that becomes 6, combine with 0, multiply with 3, that's 18, and my remainder is 20. And so your answer is going to be different too. For this one, my question was to find p of 3. I don't need all this stuff. All I need is the remainder, because the remainder is going to be equal to that p of a. So p of 3 is equal to 20, and that's it. Okay, so here's 2 you-try problems. I'll give you the answers in a couple seconds. Go ahead and try them on your own. Remember to pay attention to the missing terms and what number is going to go on the left side of the box. So check out your answers. I'm not going to talk about it all, but the work's all there, so check all your positives and negatives. A lot of times that is one of the mistakes. If you have any questions, we can answer them in class. Here's your joke. All right, so what do you get when you cross a duck with a large reptile? A quackadile. The large reptile is a crocodile and it becomes a quackadile.